Hello everyone, today I will show you about sense of vision for food in the class of teacher Mạc Thị Hà Thành. I'm Quang, the presenter, and the leader is Hoàng Thị Hải Đăng. This slide was made by Kiều Anh and supporting content was Phạm Vũ Huy and Phạm Văn Kiên. We have 4 parts. The first is an overview, and the others is about the main content of the presentation. Light is stream of photon or electromagnetic radiation moves wavelength light in the spectral region, visible to the naked eye about 380 to the 740 nanometer. Beyond that limit is invisible to the eye, which are the ultraviolet region with high energy and the infrared region with low energy. At the beginning, I will talk about structure of the eye. From the outside, basic eyes have the following parts, including eyebrows, eyelashes, eyelids, irises, pupil. Next, the internal structure. The eye is a very sophisticated internal organ in which the cornea, lens, and retina are the basic parts to ensure the eye function. Another part we can see in the image. To continue, I will show you how does the eye work. Inside the eyes are various structures working together to create the image that the brain can understand. Firstly, the cornea is a clean dome-like structure covering the iris or colored part of the eye. The lens directly below it and the retina, which lies the bed of the eye. The retina consists of thin layer of light sensitive tissue. This candle can help us understand how the eye captures images and then send them to brain. First, candlelight passes through the cornea. As it does, it's bent or reflected on the lens. As the light passes through the lens, it bends the second time. Finally, it arrives at the retina, where an image is formed. This double bending has reversed the image and turned it upside down. The next day, the image is turned right side up in the brain. Before that can happen, the image needs to travel as it burns along the optic nerves and enter the brain occipital lobe. When the image is from there, it regains its proper perspective.
The next part, we will show you the mechanism of optic nerve photoreceptors. The retina contains 2 types of photoreceptors, rods and cones. Photoreceptors are image forming cells. They are specialized type of neuroepithelial cells that is capable of absorbing light and converting it into an electrical signal in the initial state of the vision mechanism, a process known as phototransduction. Photoreceptors are packed tightly together, allowing a large number of light to be absorbed across a small area on the retina. The photoreceptors are localized around an area near the center of the retina, called the macula, which is the functional center of the retina. The fovea is located in the center of the macula. The macula is responsible for high-resolution color vision provided by different types of photoreceptors. Rod cells are highly sensitive to light and function in night vision, whereas cone cells are capable of detecting a wide spectrum of light photons and are responsible for color vision.
rods are cylindrical shaped photoreceptors. They are more numerous than cone cells with an estimated 92 million rod cells located in the human retina. Their diffusion path is low intensity light and are thus responsible for vision in dimly lit surroundings such as adult rod vision provide high sensitivity to light, but with relatively low spatial discrimination and no ability to distinguish different wavelengths to light. This way they are not wavelengths of detecting different color compared to concealed rods have both physical acuity of ability to distinguish fine detail. Cones are conical shaped cells that operate best in high intensity lighting and are responsible for the perception of color. There are 4 real cone cells in the human retina, compared to rod cells numbering approximately 4.6 million segments and generally shorter than that of rod and SNM implier and often conical, as in the case of rod cells. In rod cells, the inner segment of the cone cell has an outer mitochondrial pair and inner part containing endoplasmic reticulum. There are 3 different options located in the cone cell account for their ability to detect different wavelengths of light: red, blue, and green. In both rods and corner, the protein holding the light absorbing retinol and homologous opsin reduction in row and 3 types of spatially distinct photopsin in the corner. Some information about vision related to sensory evaluation, sensory interaction, phenomenon of eyesight. Vision can affect the sense of taste or smell by the appearance of a product, usually a product with a good appearance or a well presented. This is often appreciated for its taste and example of the effect of vision on taste. Variation equal evaluating and fancy taste of skim milk and 2% fat milk, more perception of the fat content and govern in the appearance of the milk, but when masking the appearance by tasting cold milk instead, the distinction between skim milk and 2% fat milk for two random probability. The first sensory test has the participation of vision to opacity and important property of beverage such as beer, juice, wine, tea, velocity, sign, mention, the light reflection of the product commonly used to evaluate the content on the surface of pastry by product. For color intensity applicable to a more and product. 5. Size, the size of the sample compared to standard product. 6. Shape, circle, triangle, square, factor, a pattern, visual evaluation, ability, color, green food, and generally considered healthy. People tend to like eat green food. Yellow stimulate and taste but an increased hunger. Red stimulate and taste but increased and feeling to watching to eat. Blue, black, purple, unpopular, and offer a feeling of dislike. Why? Often you accept because they make you forget the hidden calorie content. I decided color plainness, new sinus for sinus, macular degeneration. Observe a physiological sensitivity psychology.
Hello everyone, I'm Kiều Anh and I'm from Group 4. Now I would like to present about the rules of the vision in the sensory evolution part. The first of this part is the importance of vision in sensory evolution. Vision in the senses that are used first when a tactile comes into the contact with the product. Vision has to determine the probability of foods such as color, surface roughness, size, or number of surface indentations, clarity, opacity, gauziness. Visions make similar comparisons of objects when they are given together in small quantity. Special attention should be given how to the pointer is represented in sensory evolution. People often note visual information as it affects the come out of the process by using color lights through the interface with product color information, using dark containers and blindfolding people to tire. The next slide is sensory integration phenomena of eyesight. Vision can affect the sense of taste or smell, appearance of a product. Usually a product with a good appearance or a well-presented. This is often a reason or the aesthetic. A sample of the effects or visions on taste perceptions is when evaluating the affected taste or smell and to perceive smell. Most perceptions of the face contain the government by the appearance of the nose, but when marking appearance by detecting cold smell in the dark, the distinction between smell and true perceived smell refers to the random probability. In addition, in sensory assessment, people often alter visual information by using color lights to interpret with product color information. Using dark product content, blindfolding tester, or put the product into a harmonic general environment.
Hello teacher, my name is Tiến. Finally, I will present the last part of our group presentation. Sensory test cover the participation of vision, opacity, an important property of beavers such as being short wind. Roughness shine demonstrate the light reflector of a product commonly used evaluate the content on the surface of packaged product. Color intensity applicable to almost any product. Size the size of the sample compared to the standard product. Shape circle, triangle, square. Okay, continue. I will tell factor affecting visual evaluation ability color green food are generally considered healthy. People tend to like to eat green food. Yellow stimulates the taste buds and increase hunger. Red stimulates the taste buds, increase the feeling of wanting to eat. Blue, black, purple unpopular and offer a feeling of slight white. Often used as snacks because they need yield forest and higher color content. I discern color blindness, near sightedness, fast sightedness, macular degeneration, other physiological sensibility, psychology. Thank you. Have a good day.